Hello, everyone. This is Rona Palmer from eMaint Enterprises, and I'd like to welcome you and thank you for joining us for this month's Best Practices webinar. And while people are joining in, I'd just like to take a moment and clarify a little bit about our Best Practices webinars. Because as a CMMS provider, we do offer quite a wide array of webinars and educational offerings, including eMaint product demonstrations and training. But our best practices webinars are really a little bit different in that we don't focus specifically on our software, but really on maintenance strategies. And toward that end, we bring in a variety of speakers with different backgrounds to share their knowledge with our listeners. And today I'm very pleased to have with me Steve Mikologic, who is a CMRP and Production Excellence and Reliability Lead at Cargill. And so again, this isn't an eMaint product demonstration, but rather we're really going to be talking about maintenance strategies. And so today's topic that Steve will be presenting is asset criticality for proactive maintenance. And for those of you who don't know Steve, he is a certified maintenance and reliability professional with over 30 years of experience in operations management and familiar with all kinds of heavy equipment. And as I mentioned, he's currently at Cargill as a production excellence and reliability lead. He's also very involved with the SMRP organization throughout the years, and familiar with predictive technologies and different methodologies of maintenance. And I do want to say, Steve, welcome and thank you. And to our listeners, we had originally planned a different speaker, Terry Harris, who is well acquainted with Steve, who had a bit of a scheduling conflict. And so Steve did come in and save the day and was able to present today's topic. So thank you, Steve, and welcome. And Steve, while we still allow a few more listeners to log in, can you maybe tell us why asset criticality is so important to people's maintenance strategies?
I sure can, Rona, and thank you for having me, and thank you for the introduction. Asset or equipment criticality, and we'll use the words asset and equipment interchangeably in this discussion today. The understanding the importance of the different types of assets or pieces of equipment in your plant and how they interact and how they increase or decrease the risk to the business is really the basis for developing good, sound equipment maintenance strategies, maintenance practices, and it also helps to develop a very good working relationship between operations and maintenance.
Oh, that's extremely important. All right, well, before I turn things over to Steve to do his presentation, I just want to go over a couple of quick housekeeping items. We are recording today's session so that we can share the recording with all of our listeners today, and you can share it with your teams. But I do have the phones on, all of your phones on mute so we can get a nice clear recording. But Steve has agreed to stay through the top of the hour and answer any questions you might have at the end of the session. So please feel free to type your questions into the question box in GoToWebinar, and I'll read them to Steve at the end of the session. And also, he has agreed to share the slides or a PDF of the slides from today's presentation, so you can share that with your teams. And there'll be a brief survey at the end of today's session when you can indicate that you'd like to get a copy of the slide deck as well. So with that, you don't want to hear me talking. I'm going to turn things over to Steve.
Well, thanks again, Rona. Welcome, everyone. Good morning, good afternoon, and good evening. Very glad to have all of the participants online. Thanks to eMaint for presenting this extremely important topic. And the importance of the topic can't be overshadowed by many things. The risk of failure today, we all understand, is huge. And the benefits of understanding asset criticality to help avoid potential for major incidents, for problems, be it in production, in maintenance, in employee health, safety, and environmental compliance is very, very large. There are so many factors to consider when it comes to the operation of our assets in our facilities, regardless of what type of a facility you are working in or maintaining. And the arguments and the discussions that can ensue as a result of trying to understand the criticality and the risk of equipment loss is always a challenge. And so today we're going to talk quite a bit about how we overcome the challenges, how we truly identify the risks in a quantitative manner, and how we move forward to build the right equipment maintenance strategies for the right pieces of equipment and assets. So let's set the stage for this. Let's get an idea from the readers, if we could. Rona, if you could help me out here, to get a better understanding of where the participants are today. I would ask the participants to please take a look at the 5 items and select the choice below that best describes your current method for ranking your equipment. How do you rank your equipment in your plants today? And it doesn't matter whether you're in maintenance operations, in upper management, or you're a craftsperson or an operator. Take a look at those, and if you would, the poll is open. Please select the item that best fits your understanding of asset criticality.
Great. So I have launched the poll, and I'd like to say there's no wrong answers here. They'll only be shared in aggregate. So Steve is asking for an honest assessment of your current method for ranking the equipment. Maybe you don't have a current ranking or prioritization. Or maybe you have it, but it's kind of in everyone's brains. Or, well, you have one, but it was so long ago, you're not sure if it's up to date. Or perhaps you have maintenance and operations sets priorities through some regular process. I think that means to say weekly or daily or on a periodic schedule. Or lastly, do you have a full cross-functional process for ranking your assets? All right, it looks like we have about 80% of the votes in. Let me give you a few more seconds to let everyone cast their vote, and then I'll go ahead and share the results. Okay, so let me go ahead and share these. And Steve, what our listeners are saying, 29% say they don't currently have a ranking or prioritization. So I guess that's why they're interested in hearing what you're going to be sharing today. 12% say everyone knows what's important. 10% say, well, we did it a while back. And this is interesting. 30% say maintenance and operations sets priorities. And 19% say there's a cross-functional process. So we have almost 50% saying they do have a process in place and just want to, I guess, make sure they're aligning to best practices. So back to you, Steve.
Great. Thank you, Rona. And some very interesting results. And I would challenge those of you who have maintenance and operations groups setting the priorities either weekly or daily. And those of you who do not have assets ranked or prioritized, to feel comfortable that you're in about the same boat. And so we'll talk more about what that means as we go forward and how the correct way to set asset criticality can benefit all of the groups. So we'll continue on down. What we're looking at here is a illustration of what we call a PF curve, and probably many of you are familiar with this, and it essentially outlines the progression of a defect that has entered an asset or a piece of equipment, and how it goes from the introduction of that defect at point P to the catastrophic failure of a piece of equipment at point FF. And you can see it's broken up into 3 domains: the proactive domain, and this is where we can take proactive, immediate steps to eliminate defects and to keep defects from entering our assets. And if you look at the predictive domain, I also like to call this the protective domain, and this is where we do things to identify defects that have entered our system and to get those defects out of the system in a planned and scheduled manner. And then, of course, the reactive mode when we usually have to interrupt production or processing in order to remove the defect, or we have that catastrophic failure and we're forced to do a root cause analysis or some type of a post-mortem identification of the failure. So again, we're trying to push our way back into the proactive domain, and the key for all of that is equipment ranking and asset criticality. This is the basis for those proactive technologies and proactive practices and equipment maintenance strategies, and not only utilizing them, but helping to understand where and when to utilize them. The asset criticality or equipment ranking will be a key in executing all that comes after it and all of your proactive maintenance methodologies. So there are many tasks that are considered important, but again, asset criticality can determine the cost effectiveness of your maintenance program. It also helps you from a budgeting standpoint and how to utilize the right tasks on the right equipment at the right time. So why is it important to rank your assets? Well, I'm sure all of you have heard this, or maybe you've said it at one point or another. Every piece of equipment in my plant is critical. Usually if you ask a production supervisor or a production employee what the most important piece of equipment in the plant is, he or she will answer, it's mine, it's this, it's my line, it's my equipment, there's nothing more important than this. There's also some very, very big misconceptions that if any part of my plant goes down, I lose my plant. Everything is important, everything is critical. So we're going to talk about how that's more of a misconception than anything, and understanding what the factors are that determine why people make this statement. And we're also going to talk about how we should consider the assets and equipment. If you look at this diagram here, what you're looking at is an operating plant, and as you look at it, I think it's very plain to see that you can take this total page and you can see divisions, and you can see divisions that break down into lines of processing or like types of equipment. And then as you look at those, you'll notice that in many cases we have redundancy. Now, without even understanding how this process works or this plant works, it becomes very evident very quickly that perhaps, and I'll just say perhaps in this case, not every one of these pieces of equipment is the most important piece of equipment in the plant, and more than likely I could take one or more of these pieces of equipment down without bringing the whole plant down. And I think if you were to talk to any one of the people who operate pieces of equipment that have redundancy, they would eventually get around to saying the same thing. Maybe not at first, but eventually. So let's talk about what is the most critical piece of equipment. What is the most important thing in your plant? And if I want to know, how would I find out? Who would I ask? Well, I can ask the maintenance manager, the maintenance employees. I can ask operations. I can ask representatives from the employee or the environmental health or safety organization. I can pretty much ask anybody in the plant, and they're going to have an opinion. So take just a minute as I continue through the presentation and jot down the top 5 critical assets in your plant. This is not an open poll. This is just for you to kind of work along. And then take 1 or 2 of those and list why you think they're critical assets. Okay? I'm going to do an exercise as we continue through this, and I'm going to talk about an operating facility, an operating plant, if you will. And my particular plant happens to be a 1972 Ford F-150 pickup. Now, we're not going to get into the discussion about Ford or Chevy or Honda or why this make or model or whatnot. This is what we have in our plant. This is our operating facility. The purchase decision to do this was either based on low cost, best assumed reliability, or whatever it is, but this is the plant we have to operate in today. You can see there's my plant. Here's a look at a couple of the operating pieces of equipment that are in that plant, the drivetrain and traction devices. Here's the operating area for the plant operator and the power plant. And if you can see, if you look at the two photographs on the right in a little more detail, you can see there have been some modifications made to this equipment already. This 1972 Ford pickup, as it rolled off the line, didn't have silicone spark plug wires, and I'm sure it didn't have the tachometer in the lower right-hand picture. It certainly didn't have the fuzzy dice. So you can see it's been customized to some point already in this process. Well, let's talk about assets, the assets or the equipment that we have in this operating plant. In the exterior, you see we have the headlights, we have an air conditioning unit, we have brakes, we have tires, we have seat belts. These are pieces of equipment, and these pieces of equipment are somehow critical to the operation of this piece of machinery. And depending on who I speak to at any given point in time, I'm going to get an opinion. So what I'd like to do is I'd like to open another poll. And Rona, if you could help me with this again, I'd like our listeners to go ahead and consider our operating plant and rank the assets. Tell me, what asset do you think is most critical out of the 5 assets I have listed: headlights, brakes, seat belt, air conditioner, or tires? Please, if you would, go ahead and make a decision and choose which asset you think is most critical out of those 5, please.
Okay, great. Well, we've opened up the poll, and again, Steve is asking you as kind of an illustration of what he's going to be sharing to kind of weigh in on what you feel is the most critical asset of the 5 mentioned on the pickup truck. All right?
Everybody has an opinion, I'm sure of that.
Okay, it looks like yes. The votes are coming in very quickly. Up to about 85% here. I'll give them a few more seconds so everyone can weigh in, and then we'll close the polls and share the results. Okay, let me go ahead and share it, and let's see how your votes compare. Well, only 1% feel headlights is most critical. Over half, 55%, feel the brakes are most critical. 6% say seatbelt. 1% say air conditioning. They don't live where I live today. And 37% say tires. Okay, so back to you, Steve.
All right, Rona, thanks very much. And that's an excellent segue, and a very, very important point that you made, that they may not be considering where they live. And one of the biggest and most important factors in identifying the right criticality for your assets is the operating context for those pieces of equipment, and whether they're operated in a daylight time or an evening time. As you can see here, if I outline more, give you more information about my operating plant, and I tell you that it's only used during daylight hours, the headlights don't become important anymore. If it's only operated at 15 miles per hour, well, perhaps the tires and traction aren't as important as they would be if I were operating at high speeds. And again, the facility is located in a desert environment. So those of you who thought that air conditioning wasn't all that important, you can have that discussion with the operator of that Ford F-150 pickup when he's in the sweltering heat and his air conditioning isn't working anymore. So again, you have to take into consideration the operating context of your asset. And if you're operating assets in Friona, Texas, and you have the similar plant in Alberta, Canada, as we have in our business, the operating context for many of those pieces of equipment is dramatically different. And so you have to take that into consideration. You can't take an asset criticality from one plant and just overlay it on another plant and expect that your results are going to be accurate. So something to think about. The operating context is very, very important. And it's why you want to get the subject matter experts from the facility where the equipment is involved in doing your asset criticality. So how important are the brakes? Well, they're pretty darn important, and the people seem to feel that the brakes were pretty important. Amazingly enough, not too many people felt the seat belts were important, but I think if you were analyzing this failure here, and there was not a seat belt involved, the safety manager would have some significant things to say about whether or not the employee is properly protected. That has to be taken into consideration. And again, this is the kind of arguments I'm sure you've already shared at one point in time or another when it comes to what is the most critical piece of equipment or asset. And don't underestimate the cost of failure, whether it be the cost of replacing a piece of equipment or a component, or the time it takes to get that component. That needs to be taken under consideration also. So, interestingly enough, the most commonly encountered obstacle, what's the biggest challenge to doing a good asset criticality and developing good maintenance strategies? It's emotional decision making. It's people shooting from the hip. It's people who are making these decisions based on their own particular idea of how things work, or their own particular idea of how the components or the assets or the pieces of equipment interact with the other pieces of equipment in our operating plan. So, begin with the end in mind. That's a quote from Stephen Covey's 7 Habits. If you haven't read it, that's not a bad book. I would strongly recommend it. And by beginning with the end in mind, as you get into asset criticality, you want to have goals, and those goals are important. You want to be able to rank your assets quantitatively. You want to utilize some type of a structure that helps you to determine the least to most important assets in your facility based on the calculation of all of the components that are involved in that asset. Every one of these disasters was the result of an equipment failure, and the equipment failure was the result of either no maintenance practices or improper maintenance practices. This is the last thing you want to happen at one of your facilities. In order to do asset criticality ranking accurately, you need to take all of the considerations from the various operations and support roles and the potential risks into consideration. You need to look at safety issues, environmental issues. You need to look at will a failure or a defect in this equipment create a quality issue or a food safety issue? What is the impact to production if this equipment fails or this equipment begins to produce at a reduced rate? And what are the maintenance issues involved, not only cost but impact to the business? So I'd like to go through and take a few minutes here and walk through these. As I go through this next series of slides, I want to remind everybody these are examples that have been developed for this discussion, and they are not recommendations per se. The information in these slides has been taken from various segments of industry, and so again, I don't want anybody to take this as if I do exactly this or have exactly this number, this is going to be the criticality of this piece of equipment. The operating context is important, and again, these are just for demonstration purposes. So it's important that each of these areas is rated and ranked, and so I'm going to show you an example of a database as we go through this, and I'm going to show you an example of a ranking chart that will help you to understand how we go through asset criticality. We get information from all of these various sources, and we put it into a structured methodology for ranking our equipment. If you look at this criticality example, you can see the various headings: business impact, environmental impact, customer impact, health and safety, and you'll see rankings below these. These are totally customizable. You can do this type of an asset criticality ranking in various types of software, and there's some very good software packages on the market. Reliability Process Solutions offers one. You can do it in an Excel spreadsheet. You can do it on a Big Chief tablet with a number 2 pencil. The important thing is to make sure that you understand what the criteria is as it relates to your site. And again, it's very site specific. If you look in the upper left-hand corner at business impact, you can see the site cost impact. And considerations are from greater than $1 million to less than $10,000. Well, if we're working on our Ford pickup truck, we're going to customize that a little bit, and we're probably going to start with number 1 being less than $10 and number 10 being less than $1,000, because after that, we've well exceeded the cost of the vehicle, and we would probably be replacing the whole thing. So, again, this is customizable regardless of what type of software package or your approach, but certainly take it into consideration in the context of your facility, and also get your subject matter experts from your various areas involved in this discussion and get consensus on it as you go forward. So just to take this demonstration further, once you have a good understanding of what the impacts could be, then you need to start asking questions and ask them from each one of the areas to determine what the impact of a defect in a piece of equipment or the failure of that piece of equipment would demonstrate. So questions like, can we create a fire? Was there a potential for explosion? Can we have an injury or death potential? Can we create any potential loss to others? And answer these questions. Select an answer that best fits your ranking criteria and enter that. So here in this slide, you can see exactly what the information looks like as you document it. If you look in the center of the page, you'll see the tab Safety Impact is highlighted, and then there are the questions, 4 questions to ask. Is it a critical safety device? Is there loss potential? Is there a potential for injury and a potential for fire or explosion? By choosing one of those answers in each of those boxes, you get a total score, and over to the left-hand side, that total score is summed up with all of the various area impacts. So safety, in this particular case, you can see scores 140, and it's contributed to the overall total for that particular piece of equipment. And it's done for every piece of equipment. Not all forklifts are the same. Not all pieces of operating equipment are the same. So you're doing this, and you can see in the blanks, each equipment number and equipment name and equipment type and the facility location are listed. So it's specific to the equipment number. And again, you want to make sure that the questions are answered correctly. Could you have a potential for injury or death, or a potential for an explosion? You really need to take those things into consideration. And it may be true for one piece of equipment and not true for another piece of equipment that people deem is identical. They may not be identical when it comes to their operating context. So please take that into consideration. Safety during maintenance is something else to take into consideration, not just during operations, but during maintenance. Are there certain safety precautions that may cause a potential for an injury? What about injury to the operators or to even passerbys? All this needs to be taken into consideration. You get through safety and we move on to environmental, and there's, again, a set of questions we want to answer. Could you contaminate the water, the air? Do you have a reportable chemical spill potential? Exposure issues, issues to the community. A series of questions, a series of weighted answers, and those weighted answers help to identify the quantitative value of the environmental impact of a failure of that asset. You look at this failure of this asset here, it certainly creates an environmental impact. My biggest concern in this photo was the gentleman in the red shirt off to the lower left of the picture with his hands in his pockets. And I can't help but think that this fella's got the attitude that, yep, I've seen this before. And that's certainly not the attitude we want to have, and it's certainly not the situation we want to be in our facilities where these things are that commonplace that they become mundane. And again, the way to address those is through a good equipment maintenance strategy, and a good equipment maintenance strategy utilized properly develops from good asset criticality. I can't stress that enough. Understanding, again, not only your operating context, but what is your external environment? Are you close to waterways? You have to take those things into consideration. If you look at this catastrophic failure, you can see that's a terrible thing. But again, the operating context is important. If you drop that hot potato in the middle of the desert, in the sand, it's not going to have anywhere near the environmental impact that it's going to have if you drop it on a wheat field in the middle of Kansas. Again, operating context, where your equipment is, and what that failure can produce in that particular area has to be taken into consideration. You can see we're on the environmental impact tab now of our questions, and the answers to those questions are generating a numerical score that would be added to the total overall score. Food safety, again, can you create some type of a pathogen or bacteria exposure? What about allergens? What about contamination, foreign material? All of those food safety considerations need to enter into your asset criticality. Now, how do I get the answers to these questions? You get them from the experts, from your quality experts, from your food safety experts. And don't neglect your sales group or your marketing group. They're the people who are hearing what the customer has to say, and they're the people who are getting the feedback from the customers that many people on the operating floor may not even be aware of. In this particular case, you can see there's an overwrap machine here, and if you look against the right side of that conveyor, there's a bag hanging there that looks to have what I would call a defect collection device in it. And obviously, there are things that are being pulled off the line. It looks like overwrap that's not functioning properly, or something that's being collected there. Now, I can guarantee when the engineering group or the management group or whoever went to look at this machine at the manufacturer's facility saw it, it didn't have that plastic bag full of junk hanging on the side of it. So whatever happens there that gets through, improper packaging, things of that nature, they create problems for the customer, and your marketing group or your sales group are going to be the people who know more about that than anybody. Again, food safety, you quantify it, add it to the total overall. Quality, different than food safety. What about packaging? What about sealing? Can you create defects? What about product loss? Don't forget, just because the product leaves your factory doesn't mean that your liability is over with. So, on-time delivery, it's a big issue. You may not be aware of it to the extent that your marketing people are. They're going to hear about it. Just because it left your factory, it doesn't mean it's going to get to your customer in the same condition. And anything from a packaging defect situation that contributes to that can be a problem. It's interesting to note that in certain areas of the operation, and I did see one particular operation where the most critical asset, and this was in a warehousing operation, the most critical asset was the overwrap machine. Why? Because the volume of customer complaints from improper overwrap that allowed equipment to shift, that allowed equipment to become contaminated or dirty, created large volumes of customer complaints. Last thing a customer wants to do when he gets his or her shipment from you is to have to clean it off before they can utilize it. So just things like that that need to be taken into consideration. And there isn't one person in the facility that knows all the answers to all of those questions. So quality, it gets its number, same methodology. And then operations. Operations includes maintenance. How will you affect your operation? Will it create downtime? Is it a line downtime? Is it a plant downtime? Or is it just isolated to that piece of equipment? Is there redundancy in your system? Don't forget maintenance. How often do these failures occur? What are the costs? How much time does it take me to make these repairs? What is the overall impact? Do I have the resources I need? The cost of this failure, a failure like this, probably very, very expensive. I've been told there's no such thing as over-greasing a bearing. I'm not going to argue that one way or another, but I guarantee you, if you keep pumping grease into a bearing, it's going to go somewhere, and that somewhere may be the motor. So, improper maintenance activities can create downtime, and there's a cost associated with that. Reduced rate impacts, failure rate impacts, maintenance costs, product quality costs, downtime costs, all impact the overall potential for that asset to affect your production. So what do you do with this information when you get it? At the end of the day, once you've gone through and you've ranked all of your assets, you're going to end up with numbers. And your numbers are going to probably be relatively evident and have natural occurring breaks. You'll see groups of numbers. Typically, you want to look at the highest 20 to 25%. In this particular case, for our example, the criticality rating over 750 was 20% of our equipment. 50% was between 750 and 300, and then the bottom 30% had a criticality rating of less than 300. Doesn't mean that one or more of those pieces of equipment aren't important. They're just not as important. And I would caution everybody, this is not an argument to have with a production supervisor and a maintenance supervisor at any point in time about which asset is the most critical. This is used for equipment maintenance strategies, for applying technologies, for applying the proper types of maintenance, and how to do that in a structured, budgeted manner. And it's also very, very useful for scheduling maintenance activities. Many plants just cut it 25, 25, and 50, with the middle 50 being B criticality. Some plants, some companies, some methodologies use A, B, C for ranking. Some use 1, 2, 3. Some use colors, black, gray, and white. It doesn't matter how. What it matters is that you understand what your numbers are telling you from the criticality of your equipment based on all of those considerations. And there will be a few aha moments, I guarantee it. So, from a PM standpoint, from doing preventive maintenance, if you look at your equipment, again, these are guidelines. These are not cast in concrete recommendations. They're guidelines. But for critical equipment, you should not probably be skipping any PM activity. Any activity that's meant to restore an asset or a piece of equipment to its original resistance to failure, if it's a critical piece of equipment, you shouldn't skip it. If it's in the I would consider the gray area, the 50% group, you might be able to miss an activity for a cycle. You might not. I would challenge you again. You have to take each piece of equipment into consideration and what potential proactive maintenance activity you're performing. Some you may be able to skip, some you may not. If you have PMs that have multiple steps in them that address multiple failure modes, you may want to divide those tasks up into separate work orders and separate groupings so that those that shouldn't be missed are identified differently than those that you may feel have a little bit less impact on the overall reliability of the equipment. So, again, if you start, like many companies do, take the top 10% and then start to develop your equipment maintenance strategies and your plans on those, it helps you to start to normalize your maintenance activities and your maintenance workflow. You may at some point in time only deal with the top 25% of the equipment. You may take different maintenance strategies for equipment at a different criticality level. Again, these are recommendations for your top 20% of your equipment. Maybe you're going to go to synthetic lubricants because your experience or the information tells you that they are more beneficial for those pieces of equipment. Training programs, having your best maintenance personnel working on your best equipment, that's a good recommendation, but it is, again, it's not a concrete way to go about doing things. It's just a recommendation, and it's helped by that asset criticality. Stores, understanding not only what equipment is critical, but what components to that equipment are critical, and things like lead time, cost to repair, cost to install, all need to be taken into consideration. But once you have your equipment hierarchy, you have a better opportunity to make the right decisions on the right equipment first to minimize your risk and to minimize the impact on your operating environment. Developing training programs, again, you want to make sure that your critical equipment is covered. Do you have crafts? Do you have operators? Do you have people who understand how to work this equipment, what the impact of it is? Do the quality group understand what they should be looking at when they come out to inspect quality? All of this is predicated on good training and on understanding which equipment types and which pieces of equipment you should be looking at first. Do you have select suppliers? Do you have a specific level of part quality or equipment quality that you utilize? Again, it's a consideration that you have more reliable information on if you have an asset criticality. So additional benefits, it's a great team building exercise. It gets input from many areas of the plant, and it takes away those arguments that my piece of equipment is the most important piece of equipment, or this will take the whole plant down, or we can't run without this, or we can't run without that. And as you go forward, if you're in the maintenance side of the organization and you're doing your budgeting, it helps you to get your budgeting done by identifying a hierarchy and how to focus your resources on the right pieces of equipment to reduce the risk to the plant. So with that being said, and I know that's an awful lot of information to go over in a very short period of time, but again, this presentation will be available for your review. We'd like to get into the question and answer period here shortly, but before we do that, Rona, let's ask the listening audience to make one more poll and to help us along to get us started on questions and answers by selecting what do you think the biggest hurdle is for you to overcome in order to complete a thorough asset criticality list. And if you would, take a look at those 5 potential answers, choose one, and then we'll start with that and get into the Q&A period.
Perfect. All right, well, Steve is asking one more question. And during the presentation, I know many of you have typed in some of your hurdles. So we just want to kind of poll all the attendees. What do you think is the biggest hurdle you're going to have to complete, to execute on the vision that Steve is laying out of a thorough asset criticality list and apply it throughout your organization? Is it in identifying the proper equipment, getting all the right people together, convincing leadership, getting buy-in from maintenance team, or perhaps there's some other? All right, so we've got about 70% in. People are still thinking a little bit. Maybe several of these are hurdles. I didn't think to make this multiple choices, but all right, looks like we'll just leave it open a couple more seconds.
It is a challenge. It is a challenge.
Yes, it is. But you know, certainly you've also shown the challenge of not accepting the challenge. So, all right, let's go.
It is not insurmountable. I'm sorry, go ahead.
Let's go through and share the results then. It looks like 28% have said it's getting the right equipment identified. About a quarter, or 24%, say getting all the right people together. About a quarter, say, or 24%, convincing leadership of the need. And then it's interesting, 12 and 12. So that's another 24%, say, convincing the maintenance team or some other. All right, so a fairly even split here.
I'm laughing, and only because I have experienced all of those in my career. And there is, as you said, Rona, there's no wrong answer when it comes to this. These are all very difficult challenges. And getting representatives together and convincing leadership of the need sometimes go hand in hand. Why should I loan people to you? Why should I do this at all? Don't you know? shouldn't you understand? So being able to speak intelligently about the cost, the impact of the risk of down equipment as it relates to the cost of operating, the cost of repair, the cost of environmental considerations, the cost of product upsets. Those are all very valid arguments and demonstrable pieces of information that you can give to your representatives and your leadership to help convince them that, believe me, we need this kind of participation and we need this kind of information in order to make the best equipment maintenance strategies and the best maintenance work processes that we can. So, how about some questions, Rona?
Okay, well, we've certainly had quite a few, so please continue to type them in, and we'll try to get to as many as we can within the hour. You've already touched on this, but we have some listeners that have said they started down this path, but you know, resistance to change is such a, we've done whole webinars on this, but maybe in your experience, that seems to be the hindrance, just resisting change. Do you have a quick tip or two on some things that have helped you overcome this resistance? You have mentioned the risk and the cost, but any other specifics on sort of resisting change and changing the culture?
Sure. And I will go back to cost. Learn to talk in dollars and cents, because that's what the leadership talks in dollars and cents. The other key to executing this is patience. You have to be patient, and you have to have the courage of your convictions. When you start down this path, don't hesitate to remind everybody who was involved that, oh, by the way, you were a part of this decision, and we agreed that these decisions would be binding. That's part of doing the asset criticality with all of the groups involved. And it's either not maybe necessarily the individual you're speaking with, but his or her representative. So, again, be patient. Change comes over time. This is a very, very, very big change when it comes to things like stocking spare parts and which parts should be stocked versus which parts are stocked. Many times when you're working under a budget constraint, you're going to have to remove parts, or you will, as part of your equipment maintenance strategy, identify parts you just don't need in your facility anymore that are taking up space and costing you money to maintain. If you eliminate those parts, you're going to eliminate somebody's perceived safety net. So there's always going to be that little bit of resistance as you go through that. Referencing the asset criticality will help you. And be patient. You will get it done.
Excellent. And you know, you've also touched on the measurements, and you know, we have many of our clients that are using, because you know, eMaint as a CMMS, and I'm sure there are many others, support asset criticality and let you consider that in the rankings of your PMs, let you look in that in reporting. And I gather, like anything else, if you get started, we have a saying at eMaint, sometimes done is better than perfect, and you get started and you continue to measure, right, the impact and then improve.
Yeah, it's a journey, not a destination. And don't forget, you're going to be adding pieces of equipment to your plant. You're going to be removing pieces of equipment in your plant. You can't do an asset criticality every day or every time you add a new piece of equipment. But so my recommendation is look at it at no more than every 2 years, and maybe annually, depending on your changes in your plant. But you need to set aside time. Get the team back together, say, hey, we've eliminated these pieces of equipment, they're off the list, we've added these, or the operating context has changed, and do those considerations. You can move through that rather quickly once people become familiar with the operation. And as an aside, when you initially do your asset criticality, it's going to start out very slow. People are going to want to talk about everything. Good facilitation, staying the course, will help the group as they go forward. They will get more comfortable with the process. They will stop arguing and bickering, and they will move through the process, and it will gain momentum. And by the end, it will feel very comfortable. So the same goes for the the costs associated with it, and everything else.
Excellent. Well, some related questions that came up to that. We have some listeners asking, at what level do you perform the criticality analysis? Is it at a system level? Is it as equipment, at a component level? And maybe you can give a couple of different examples of levels in different industries or for different systems.
Yeah, sure. Good question, and that's an excellent question, as a matter of fact. So we recommend you do it at the equipment level, and in some instances you are going to have subcomponents or an equipment breakdown, and if you do, typically what we recommend is that you apply the asset criticality of the asset or equipment to the sub-level or components and utilize the standard ranking for the equipment. So if you have, for example, you may have a screw conveyor that has a significantly large gearbox on it that you would deem an asset, and it has a very large motor on it that you would deem an asset. But the piece of equipment, we would consider the screw with its components from the drive to the discharge, and say that is the piece of equipment, and I would rank that piece of equipment. Now, the motor may have an equipment number depending on your maintenance management system and how your hierarchy is for your equipment. They may have separate numbers, but I would recommend, the recommendation would be to utilize the piece of equipment in its entirety, and the various components or sub-pieces of equipment take that criticality from the equipment. Again, generally.
Right, I realize these are all guidelines, and what I'm taking away too, that these are guidelines, but what's important is that you just do apply them and apply them consistently. Also, they're asking who should be, as you start to put together this criticality team that's going to be, ranking the assets, who do you typically recommend are the important people to have be members of that team?
Well, someone who represents maintenance. It may be the maintenance manager. It may be, again, depending on your managerial hierarchy, it may be a superintendent. You're going to probably do it by areas. If you think back to the picture we showed, there were of the operating facility, there were various areas, and those areas, again, whether it be by line, if you're in a multi-line production line type of an environment, it may be by line, it may be by component. In the mining industry, you'll see if it's subterranean mining, you'll see usually underground components will be ranked, and they'll have their own equipment maintenance strategies and hierarchies much different than the surface operations. Many times you have mobile fleets that are associated. They would be ranked and handled differently. And you may have common team members from safety or from marketing or from operations or from food safety, but you may also have different team members that are subject matter experts in those particular areas. So you take your natural divisions in your facility. That's the easiest place to draw division lines and to start breaking that down into manageable chunks.
Great, and we've had someone, this is a fairly common, HVAC equipment is so common to no matter what your industry, right? We even talked about it in the F-150 example, but, any strategy tip when you're just dealing with HVAC units? I think this person might be a facilities manager, where that's a concern about looking at perhaps you can just shed a little light on an HVAC example of applying criticality, because it is so common.
Yeah, great question, and it applies to all of the utilities, not only HVAC, but electrical, lighting. If you have gases or plant air or water, whether it be cooling water or potable water. These are systems, if you will, that are common to many, many different areas of the plant, and the considerations need to be and may be different depending on the areas of the plant and the needs of a particular area of the plant. So overall HVAC I would do as a system, but and lighting I would do probably as a system. But if I'm in a situation where quality has a significant impact based on lighting, if I have specific lighting that operations personnel or quality personnel or food safety personnel need, then that criticality in that particular area may change. So you would have in this particular case, you'd have an overall ranking for your system, and then you may have a much higher criticality ranking for a particular component, and you may want to divide that up into its own, give it its own equipment number for an individual ranking, or you may assign it to the operating asset that it is intended to service. So there's, again, a couple of different ways you can approach that, but there's nothing wrong with taking the overall system as a piece of equipment, but be considerate of specific cases, and don't forget your operating context. HVAC, air conditioning may be more important in Texas or New Mexico than it is in Ottawa.
Right. We've also had a listener ask, and perhaps this applies to when it's new equipment where you may not have a lot of history on yet. How do the manufacturers or the OEM manuals fall into the process of defining criticality?
Yeah, and that's a great question. And the answer to the utilization of manuals is that they are a very good guideline to help you if you have little or no understanding about the potential defects that may enter this equipment. But I would not recommend utilizing those as part of your asset criticality, simply because, and I'll go back to the very beginning and the operating context. When a piece of equipment is designed, it's not designed to typically not designed to function in any locale. It's built in an environment, it runs well in that environment. That doesn't mean that the application of that piece of equipment in an operating environment is entirely different or exactly the same. So those things need to be taken into consideration. You may need to change the lubricant from the recommended lubricant to a higher quality lubricant, maybe because of heat considerations or cold considerations. You may need, you may be in a marine environment that has extremely larger risk of corrosion. So you have to look at your coatings differently and the impact of that particular defect as opposed to it sitting inside a temperature-controlled environment. So again, you need to consider that piece of equipment where it's operating. The manufacturer cannot do that for you. It's not in the manuals that way. Those are recommendations based on their best knowledge of their experience with their equipment, not your experience with their equipment. That's why maintenance considerations and failure rates of existing equipment, if they're known, are a part of your asset criticality determination.
Perfect. Well, thank you so much, Steve. You know, we could go on for days here, but
oh yeah.
And we really do appreciate you giving us such good practical insights and sharing really a wealth of experience. And before we wrap up, I know there have been more questions, and we've had many specific around how eMaint does this. And of course, as a CMMS, we do have the ability to apply asset criticality rankings in how you prioritize your PMs, and people apply them in dashboards and measure on-time PMs differently on your A's, B's, and C's. We've also had questions about the database that was shown as an example. But today's presentation was purely educational. we don't make this commercial, but if you did want to get any more information about eMaint, if you're an existing customer or a prospective client, or about the database, there's a little poll at the end, and just say, please send us some more information, and we'll be happy to put you in touch with Steve, with the person who built, one of our partners who has that little handy Access database that you can use, and of course to get you in touch with more people on how do I do this in eMaint. All right, but for now this was really about the strategy and the application, and thank you so much, Steve. I learned a lot from all these sessions, but I have to admit today was really a master class on how to do this. And thanks to all of our listeners for your active attention and all your participation. And thank you, Steve. And
my pleasure. Before you close, I want to thank you for excellent facilitation. All of the listeners for their participation. It's really been fun. And yes, please utilize Rona and the poll and eMaint, and you can contact Reliability Process Solutions if you have questions about it. And I will stress that if you have a CMMS and it doesn't have an asset criticality indicator, I would consider upgrading because it's very important. Sorry, Rona, I had to throw that plug in.
It's fundamental, right? It is the foundation. And also, as Steve mentioned, he is a member of SMRP. There's a wealth of information available at smrp.org. We are an approved provider, both eMaint and Fluke, as I forgot to mention at the beginning, but most of you probably know by now, eMaint is a Fluke company, and we both participate at SMRP, and we encourage you to check out the SMRP website for more information from people like Steve and others. But till then, when I conclude this, there will be a poll. Please let us know how we did and what other types of presentations, what's on your mind, what other topics we can present that are important to you. All right, so till then, thank you, everyone, and we'll see you all the next time. Take care.
Thank you.
Take care, Steve.
Bye-bye now.